The Czinger 21C Evolution is a modern hypercar built with advanced 3D printing technology. It is designed for both the street and the track, and it represents a new way of building high-performance cars. This car is created by Czinger Vehicles, an American company founded by Kevin Czinger. The main goal of the company is to change how cars are designed and manufactured by using digital engineering and additive manufacturing, instead of traditional factory methods. Unlike normal car companies that use large casting and stamping machines, Czinger uses 3D printing to produce many important metal parts. These parts are made layer by layer with high precision. This process reduces material waste and allows engineers to create complex shapes that are lighter and stronger than traditional components. Because of this method, the 21C Evolution has a very strong but lightweight structure. The design of the car is focused on aerodynamics and efficiency. It has a narrow body shape that helps reduce air resistance. One of its most unique features is the tandem seating layout. In this layout, the driver sits in the front center position and the passenger sits directly behind the driver. This setup improves balance and allows the car to have a slimmer front profile, which helps with airflow at high speeds. The exterior design looks aggressive and purposeful. Large air intakes help cool the engine and hybrid system. Sharp lines guide air across the body. A large rear wing adds stability and increases downforce when needed. Every part of the body has a clear engineering purpose. Nothing is added only for style. Each element supports performance, cooling, or stability. The chassis of the 21C Evolution uses a carbon fiber monocoque combined with 3D printed metal structures. This combination provides high strength while keeping weight low. The use of advanced software allows engineers to test and improve parts digitally before they are physically produced. This saves time and improves accuracy in manufacturing. The Czinger 21C Evolution is not just another fast car. It shows how digital design, robotics, and 3D printing can work together to create a new generation of vehicles. In the next part, we will look at its engine system and performance details. The Czinger 21C Evolution uses a powerful hybrid system that combines a twin-turbocharged V8 engine with electric motors. The engine is a 2.88-liter flat-plane crank V8 designed for high performance and efficiency. It is mounted in the middle of the car to improve balance and weight distribution. This engine works together with electric motors placed at the front wheels to create an advanced all-wheel drive system. In its Evolution specification, the total power output can reach up to 1,700 horsepower. This high level of power allows the car to accelerate from 0 to 60 miles per hour in about 1.9 seconds. The strong hybrid system also helps deliver instant torque, which improves acceleration response. The electric motors provide immediate power while the V8 engine builds speed, creating smooth and continuous performance. The top speed of the 21C Evolution depends on the configuration. In low drag setup, the car can exceed 250 miles per hour. In high downforce track configuration, the focus shifts from top speed to cornering performance. The aerodynamic system can generate a very high amount of downforce, helping the car stay stable at high speeds and during sharp turns. The transmission system is designed to handle extreme power. It sends engine power to the rear wheels while the electric motors drive the front wheels. This setup improves traction and control, especially during hard acceleration. The advanced control systems manage power distribution between the front and rear to maintain stability. Weight plays an important role in performance. Thanks to the carbon fiber structure and 3D printed components, the car weighs around 1240 kilograms. This low weight combined with very high horsepower gives the 21C Evolution an excellent power-to-weight ratio. Braking is managed by carbon ceramic brake discs that provide strong and reliable stopping power. These brakes are built for track use and can handle high temperatures without losing performance. The suspension system is also adjustable, allowing drivers to set the car for road comfort or track precision. All these systems work together to deliver extreme performance. The Czinger 21C Evolution has a design that is focused completely on function and performance. Every part of the body is shaped to improve airflow and cooling. The front of the car is narrow, which reduces drag and helps air move smoothly along the sides. Large air channels guide air toward the radiators and engine bay to control temperature during high-speed driving. The body panels are carefully engineered to balance downforce and stability. One of the most important aerodynamic features is the large rear wing. It is adjustable and can change its angle depending on driving conditions. In track mode, the wing increases downforce to keep the car stable in corners and under braking. In low drag mode, it adjusts to reduce air resistance and help the car reach higher top speeds. The underbody of the car also plays a key role by managing airflow beneath the vehicle to increase grip. Inside the cabin, the tandem seating layout creates a unique driving position. The driver sits in the center front position, which improves visibility and control. The passenger sits directly behind the driver. This layout keeps the car narrow and improves weight balance. It also gives the driver a focused and race-inspired environment. The interior uses lightweight materials such as carbon fiber to reduce overall mass. The dashboard includes digital displays that show important driving information like speed, power output, and system status. Controls are placed within easy reach of the driver to maintain concentration during high-performance driving. The seats are designed to provide support during fast cornering while remaining comfortable for road use. Advanced software is used in the development of the 21C Evolution. Engineers use digital simulation tools to test strength, airflow, and performance before producing parts. Many structural components are made using 3D printing technology, which allows complex shapes that are both strong and light. This method improves efficiency and reduces unnecessary material. The suspension system is fully adjustable, allowing the driver to change ride height and stiffness. Sensors monitor vehicle behavior in real time and help maintain stability. These technologies make the 21C Evolution a highly engineered and precise hypercar built with modern digital methods. The Czinger 21C Evolution is produced in very limited numbers, which makes it rare and highly exclusive. It is not built on a traditional mass production line. Instead, each car is assembled using a mix of advanced robotics and skilled human work. Because many parts are 3D printed, the company can update and improve components without expensive tooling changes. This flexible production method allows faster development and more precise engineering. The price of the 21C Evolution is in the multi-million-dollar range. This reflects its advanced hybrid system, lightweight construction, and innovative manufacturing process. Buyers are not only paying for extreme speed, but also for new technology that could influence the future of the automotive industry. Each vehicle represents a combination of digital design, artificial intelligence, and high-performance engineering. One important advantage of additive manufacturing is reduced material waste. Traditional manufacturing often removes large amounts of material to shape a part. In 3D printing, material is added layer by layer only where it is needed. This improves efficiency and can reduce environmental impact. The use of lightweight materials also improves fuel efficiency and overall performance. The 21C Evolution shows how modern technology can change the way cars are built. It combines a powerful twin-turbo V8 engine with electric motors to deliver extreme performance. It uses carbon fiber and 3D printed metal parts to reduce weight while maintaining strength. Its aerodynamic design increases stability and control at very high speeds. All these elements work together to create one of the most advanced street-legal hypercars available today. This car is not just about breaking speed records. It represents a shift toward digital manufacturing and smarter engineering solutions. As the automotive world continues to evolve, technologies like 3D printing and hybrid performance systems will become more common. The Czinger 21C Evolution stands as an example of what is possible when innovation meets performance. Thank you for watching this video. If you enjoyed this content, please like the video and subscribe to the channel for more automotive videos.